So, in recent years, we've heard a lot about fusion in the news, but where do we get the ingredients that make up fusion? First off, we need to talk about the difference between fusion and fission. Fission is a common energy source, at least in the United States, that uses uranium as its fuel. It takes that uranium and it splits it up, and those fission products have a lot of energy, and then that energy can be converted into heat, turn a turbine, and give you electricity. Fusion, on the other hand, instead of taking a very large atom and splitting it, you're actually taking two very small atoms and bombarding them into each other, creating a slightly larger atom and lots of energy. So what comprises of those small atoms that need to be bombarded into each other? There are actually several different flavors of fusion out there that comprise of taking different hydrogen isotopes, which are the lightest isotopes you can get, and bombarding them into each other. The first thing we need to know is what the heck is an isotope? So we're all pretty familiar with the periodic table of elements. This here tells you how many protons are in the nucleus of an atom. And the number of protons tells you what elements you have. It also tells you how it's going to behave chemically. But this is only a part of the story. We all know that a nucleus of an atom comprises of both protons as well as neutrons. So all of these different elements, they have a certain number of protons, but they can have all sorts of numbers of neutrons. Hydrogen, for example, which we're going to talk about here soon, can have at least 3 different numbers of neutrons, 1, 2, or no neutrons. But in a chemical sense, it's always going to behave the same way. These isotopes here are what comprises the isotopes of hydrogen. You could see protium with no neutrons, deuterium with 1 neutron, and tritium with 2 neutrons and the proton. All of these having 1 proton. Fusing together any combination of these hydrogen isotopes is considered fusion. In fact, the sun actually uses protium when it comes to fusion. So when you hear about fusion in the news, which of these isotopes are we typically talking about? Well, it's typically deuterium and tritium. You can fuse deuterium and deuterium with each other in what's called DD fusion or deuterium-deuterium fusion, but the most efficient way to do fusion is deuterium and tritium combined in DT or deuterium-tritium fusion. So where the heck do we get this mass quantity of deuterium and tritium? We can actually get deuterium from just regular old tap water. 1 out of every 6,500 hydrogen atoms is deuterium because it occurs naturally. So you might have realized we have kind of a problem here. I mentioned that deuterium behaves chemically the same way as hydrogen. So how the heck do we get it out of this water? Well, thankfully, when deuterium is attached to a water molecule, it's slightly heavier than a regular water molecule. In fact, we call it heavy water. One of the things we can do is take advantage of this physical difference and boil the water. Typically, you know that water boils at 100 degrees Celsius, but deuterium water or heavy water boils at 101 degrees Celsius. So if you can just simmer that water to boil away the regular hydrogen water and leave behind some of that deuterium water, you will have a lot more deuterium left over after a while. Then after that, you can do some electrolysis to separate the deuterium and the oxygen, do a little bit more purification, and you're able to get pure deuterium. Tritium, on the other hand, is a lot trickier to get a hold of. Now, tritium, like deuterium, does occur naturally, but it doesn't build up in our water. That's because tritium, unlike deuterium, is radioactive with a 12-year half-life. So it just can't build up to large amounts. In fact, 1 in every 10 to the 18 hydrogens are tritiums. So with tritium, we have to be a lot more creative to get a hold of it. In fact, we have to create each individual atom. And we do that typically by bombarding lithium, specifically lithium 6, with a neutron. Lithium 6 is that specific flavor of lithium that has the 3 protons and 3 neutrons to make a total of 6 nucleons. One of the things that we do is we take rods of lithium 6, we put them down into a nuclear reactor, such as the reactors that you can actually get power from. And those reactors have all sorts of neutrons that it can give up to the lithium. Then the lithium splits and creates helium and tritium. But that's not the only way to create tritium from lithium. Fusion researchers have planned on doing this kind of lithium blanket that surrounds the fusion reactor. It can act as a coolant to remove that heat to be used for steam making purposes and electricity. And it doubles as being a breeder blanket. So you can take those neutrons that are coming out of the fusion reaction to activate the lithium and create those tritium molecules. And then after that, all you need to do is take the tritium out of this blanket and feed it right back into that reactor. These style of reactors are able to create their own tritium indefinitely. And all you got to do is give a feedstock of lithium and also feed in that more common deuterium. And that's where you get your deuterium and tritium ingredients for the future of fusion.